Welcome back to another exciting pre-class video. This time we'll be talking about inverse trigonometric functions. Remember that an inverse of a function is a new function that undoes the original. For example, if we have a function that takes the temperature in Fahrenheit and converts it to Celsius, the inverse of this would take a temperature in Celsius and convert it to Fahrenheit. It undoes the original. We can use the same logic with our trig functions. Our original trig functions, like sine of alpha, take in some angle alpha and output a value on a unit circle, which means our inverse trig functions should take in a value on a unit circle and output an angle. Let's take a look at some notation. This new inverse function for sine is called arcsine and is sometimes written as sine to the power of -1 of a. Well, notice this does not actually mean sine to the power of -1. Rather, this is a special notation that says this is a new function that is the inverse of sine. Similarly, we have a function called arccosine, sometimes written cosine to the power of -1. And again, this is just the inverse of cosine. This is the function that undoes cosine. One thing we need to be aware of is that sine inverse of some angle does not equal 1 over sine. And cosine inverse of an angle does not equal 1 over cosine. So with that in mind, let's see what happens if we try and evaluate some of these functions. Remember, sine of some angle alpha gives us a coordinate on the unit circle. That tells us that theoretically, arcsine of some y coordinate on the unit circle will give us the angle that gets us there. So if we have arcsine of root 2 over 2, we know that the angle that produces that y coordinate is pi over 4 radians. Similarly, arccosine of 1/2 tells us that the x coordinate is 1/2. We're looking for the angle whose x coordinate has 1/2, and that's pi over 3. As a quick sketch of this, arccosine of 1/2 equals pi over 3 is the exact same thing as cosine of pi over 3 equals 1/2. In class, we are going to figure out what angles we can use with these inverses, find values of various inverse trig expressions, and if we have time, we'll do our muddiest point.